Hello, this is Tom Zeppeveld from Ophelia with a small screencast about how we used Prologram in combination with Neo4j to model process flows. Here in this diagram you have a flow that consists of stage nodes and test nodes for branching, and between each nodes there is a transition with in this case a duration and whether it's the default flow or not. So after a certain test you can have a result that is in this case a result true and a result false, and here the result true is a default, while after this test there is a result false which is the default. And you can have loops that go back and to implement cycles. When you, of course, with all the durations, you can easily calculate the duration of a normal flow. I have here a list of queries. I have my process model days, which is 41, and it's an easy cipher query calculating the path, and for all the paths that have transitions where the default is true, and then it calculates the normal the total of days in the optimum, well, the default flow. Okay, how do we model now instances of this flow? I have the possibility to include through this filter, okay, an instance. So this is my instance with an ID simple, and it has a transition of 7 days instead of 2 days, and apparently this instance of the process has only gone to stage B, so normally the rest of the flow would be like that. Of course we can calculate that also if I have a get process path and I have my simple loop, then it calculates the flow. As you can see, it goes from start to B, and then it switches to the model. So this is this link, and then it follows the rest of the flow. Since this transition took 7 days, normally it would have taken 2 days. It is also possible to calculate the expected total duration of the process that has started over here. So I have get process days, and then it should be 46 because it's 5 days longer than the original one. 46. I now have a simple short process, but for instance, if you have a process with a loop in it, then it had started over here, it went to B, C, then the first test resulted in a transition to G. So then next step, this would be the normal, the flow. And also here you can calculate the path. So I have one loop, and then you have, so this process, let's go to G, and then it goes passes the test one again, and then hopefully it goes like this. It also works with multiple loops. So I have one loop, I have now the multi-loop. So then after test 1 it goes to D, test 2 fails, and then it goes to H, so then it goes back to here, and then the second time test 1 fails, it goes to G, so it would be go like that. Kind of long process, but even here this model works. If I have get process days and then I have the multi-loop, then I can calculate the path, which is now quite long and has in total 5 times a test in it. And if you want, you can calculate the expected length of the process also in the same which will cost probably 76 days. And here this query, it works a little bit like this. You get first you calculate the path which is in the instance, and after the instance, the last node, you go to the part of the path that is still in the model, and you calculate the two totals of days, the instance days and the model days, and then you you sum it. So this is how we can do this in our Prologram system on top of Neo4j to explore and execute Cypher queries on top of Neo4j. Thank you for watching.